But before I talk about Docker, I would like to talk a little bit about containers, because I think it's important to understand how the technology works and then to talk about the product. Another thing that I would like to do is tell a story about how Docker appeared and where the idea came from. So we will go a little bit back in time to see how we were doing things before, how we are doing things now, and how we will do in the future. So, back in the days when we were creating new applications, we had to create a server and an application, and the two things were deployed together, one to one. And this had a problem because the physical layer of the server was not utilized 100%. So there was a big waste of resources. After a while, some companies like VMware and Citrix came with a technology called the hypervisor that allow people to create virtual servers over a physical machine. And in that way, we were able to deploy multiple applications in isolated environments over the same physical layer, and we were able to optimize our resources a bit more than before, because before we were ending up with servers in the data center not being efficient, consuming 10% of the hardware. So this was a revolution. The technology was so good that we ended up creating many different virtual machines. The technology was good but was not perfect. The problem of this technology was that for each virtual machine we had to install an operating system. And operating systems, they consume many resources of the physical layer. Even without installing any application, only to run the operating system, we are already consuming some resources. So, and if we think about it, the only reason why the operating systems exist is to facilitate the application. So if we could spin applications without operating system, we would, right? Like if it was possible. So this is where the idea came from. So having more operating systems doesn't bring more business value to corporations. And some operating systems even have licensing, and licensing is expensive. When you start spin up different virtual machines, you end up to pay a big amount of money to keep them running. So something had to be done, and something was done with the container technology. So the idea is a container is kind of a small operating system, minimized. So it's lighter. Container technology would be the more efficient solution at the moment. Why containers are lightweight? They consume less memory, they consume less disk space, and they consume less CPU usage compared to VMs. And before containers, when we didn't have this technology, we used to deploy multiple applications in the same user space. So we have cases like this in our servers. We have multiple applications running in the same runtime, OS runtime. So the difference with containers is that we are able to create multiple user spaces, and our applications run in isolated environments. So everything is isolated, so application A doesn't interfere with the neighbor application. Why they are lighter and why this is possible, that they start up faster, they are lighter, and how they are more portable. Because containers share the same kernel of the operating system. So the kernel, there's only one kernel running in the whole physical server. This is how the technology came up. So the idea was...
So the OS, you've got two containers there on one OS.
Yeah.
Do those containers have to know what OS that is?
They need to know, and they need to be specific for that kernel.
Okay.
I will explain that in other slides. So why do we need isolation? Why, instead of doing this, why we don't continue installing multiple applications in the same operating system? So we had, I think it was 1 month ago or two, a real example that happened. So a long time ago, we installed an application called Connectivity Portal, and that Connectivity Portal to run was using a library that I think it was Oracle adapter to access Oracle database.
Yeah.
Later on, someone installed a different application called GRV, and with that application, someone installed a new version of that library. So what happened? The first application stopped working because the first application was not ready for that library. So this is why isolation is important and why we should, and this is one of the advantages of using this kind of technology, containers, that we are able to run multiple applications on the same physical server using even different versions of the same library, and none of them will affect the other. So this is the advantage of isolation. And this is not something new. This exists for a while, not in the enterprise world, but exists in our mobile phones, Android phones and iOS. Each application is in a controlled environment. That's why they work so well, they don't break others. And how this is possible? How can we achieve isolation? So to achieve isolation, for each container we need to have an independent root file system, an independent process tree, isolated process tree, and an isolated network stack. So what is isolated root file system? Isolated root file system means that the application that is running on the container number 1 has its own root file system and can create, update, and delete files without affecting any other applications that are running in the same machine, because there's kind of a wall between them. Isolated process trees means that each container will have its own PID1, that is the first process that starts, and it will have a hierarchy of processes, and they are independent between containers. And that means that, for example, if we have a process running in container number 1, this process cannot communicate with other containers. There's again a wall between them, so we cannot send a sign-off from a process running container 1 to container 2 and stop a process on container 2. It's not possible. Isolated network stacks means that each container will have its own IP address, own range of ports, and even configurations related to ports and mappings. And how this is possible? So this is possible using some features from the Linux kernel at the moment, because Docker only runs in Linux. And that feature, the main feature that creates the isolation, is called kernel namespaces. And this handles all those things that I talked before. Another feature imported from Linux that is used is called control groups. Control groups it's a way that we have to create limits for the containers. For example, like we do in the virtual machines, that we define, okay, this virtual machine will only be able to use 4 gigabytes of RAM and 20 gigabytes of hard drive. The same thing we do it with control groups, and we can define strict rules between containers, and this will allow us to create protection. For example, if we didn't have this, if we had an application that decided to consume all the resources from the physical machine in the container number A, the container A, sorry, that process would probably create problems in the other containers because it will consume all the resources, and this will create a denial of service.
So does each container get a slice of the underlying OS, and it's limited to that?
Yeah.
You don't
Yeah. It's exactly like
the resource requirements per container as well.
Yeah.
And in aggregate, it cannot exceed what's available in the OS.
Memory, CPU, you name it, all the properties from the operating system.
I think ideally you kind of you couple your container with your application, so you know your application would run within a certain limit, and you define that on the container, and then when your application needs to run outside that limit, you actually spin up multiple instances of it and scale horizontally rather than trying to scale vertically by increasing the RAM and CPU available per container. You just implement multiple containers with the same instance of the application. So it changes how you design your applications a little bit to be able to scale horizontally like that, but it means then that you can dynamically at runtime scale horizontally. And where it goes is that when you get into the cloud infrastructure, where you're basically paying for what you use, you can just scale up for high demand, and then as soon as the high demand drops, you can scale back down automatically. and you only get charged the extra for the bit you used at that time.
Yeah, but this is, I understand what you're talking about the architecture itself, but this is a little bit more simple. It's exactly limits for the operating system, and they can be tweaked all the time. For example, you can start by using 20 gigabytes of hard drive, and then your application needs more, and you can always tweak and give more to that specific container. You don't have to run another one, for example, to have more disk space. For example.
Yeah.
You know what I mean?
Yeah, like that's what we typically do with the VMs. We
Yeah.
scale the VM up, but I suppose the container lends itself more to horizontal scaling than vertical scaling. Is the only
Yeah.
thing I'm saying.
But yeah, exactly. And this is more like, this is a lot more flexible than the things that we can do with VMs. I didn't went very deep into it, but people say that it's a lot more flexible. And the final feature that is vital for the use of this technology, it's called capabilities. And capabilities is something, it's kind of a granular definition of rules that the process or application would be allowed to execute. So things like, for example, let's imagine we have a process that needs to create a socket and assign a port to that socket. So for that we need to give this specific capability, NetBind service, that does exactly that, allows that application to be able to execute that function. So this is related with the security of the application, because we don't want to give root access to an application, because the application can start doing things that we don't want the application to do, or even users, because you can do the same. You can apply capabilities to users, not only to applications and services. Okay, now that we have an idea what is the technology of containers, now we can start talking about Docker. Docker is a product, and it's an implementation of the technology. So it's a product created that leverage all those things that we talked before about the Linux kernel. The capabilities, namespaces, C groups. And Docker is not only a technology, it's becoming a platform too. Because it started with a runtime, but now it's becoming a set of tools that it's growing. How can we use Docker, and how does it work? So let's imagine that we can install the Docker engine in different environments. So we can start by installing the Docker engine in our laptop, start developing the app, create a container for the app, and then after that, it's super easy to deploy that application anywhere you want. And what I mean by anywhere, I mean like in the cloud, in the Amazon Web Services, Microsoft Azure, or even in your private data center that just need to run the Docker engine for it. And it's very easy. And basically, this was what created the buzz around Docker. You know, this was the factor that people start looking at it and say, wow, this is really amazing. Finally, we have something like this in the enterprise. So as I said before, Docker is becoming more than a runtime engine. So there's Docker registry. They are working in applications for clustering, orchestration, network, and they are improving all these tools. Some of them are not final yet, are still in beta version. The registry is very interesting. It's perfect for the vision of Citgo in terms of having a store of applications. A registry is a place where you upload your images of software, and then you can, sell them, create infrastructure around it in a way that you can push and pull those images in an extremely easy way.
Yeah, it's not just that it's your application plus all your applications dependencies that it needs to run all in one bundle.
Yeah,
so
package.
And then it's running on that kind of virtual Docker engine layer. So anywhere that Docker engine layer, you just drop your app or your container onto it, and there you go. There's no more, did I get this library? Did I forget this? Do I have the wrong version? Just drop it and go.
Yeah, I will make a demo after. You'll see how easy it is. It's incredible. So let's talk about a little bit about the history of Docker. So Docker was created in a company called .cloud that now is formerly known as Docker Inc. The lead developer of Docker is a guy called Solomon Ickes, and Docker is written in Google Golang. This is the logo of the language. It's a language from Google, and it's licensing under the Apache 2 license, open source. That means people can use it, change it, modify it. So what will be the future of Docker? At the moment, Docker only runs under Linux architecture, so it's only supported by Linux. But Microsoft is working on Docker Inc. at this moment, working in a version of the Docker engine that would run over Windows Server operating systems. And now you guys might ask, yeah, but why do I need Docker in Windows Server? Why I don't deploy my .NET applications on a Linux kernel or on a Linux machine? Well, that's not possible because that application, that Windows application, is expecting to work with some features from the Windows kernel that you don't have on the Linux kernel. And the same thing happens if you try to deploy a Linux container over a Docker engine that is running inside of a Windows machine. But this will change, and we will be able to have both flavors. Other things that will come up would be hardware assist. So companies like Intel, AMD would probably start manufacturing their hardware to support containers and start them faster, even faster. They start super fast, but it's possible to do different things and increase security restrictions at the hardware level. So this is something that might come up. And Docker is really useful for architectures like this, microservice architectures. That microservice architecture is kind of a set of applications and services that are running in isolated containers, and they work all together as a single application, all application, but they are small pieces, small applications working together as a whole application. They have lots of advantages, and this is what people are talking now, that it's like the next big thing for software architecture, because solves many issues. And Peter will talk about this more specifically in the next presentation, but I can tell you some advantages of these kind of architectures. One of them is like you are able to update parts of the application without having to upgrade the whole application, and sometimes you don't even have to create downtime for the application. The application continues to run, you are updating parts of it, and the user doesn't even notice that is happening. Lots of cool things like self-healing of the application. Imagine if something goes wrong with a patch, the application is able to roll back, and the user doesn't even notice that the problem happened. So this is really cool. Other thing is highly scalable. So because we have all these pieces isolated, we are able. Imagine we start our application with a small group of users, 100 users, but then after a moment we start having a lot more users, and we have this ability of scale. So we can start, for example, different proxies for the website. We can create load balancers, lots of things, even cache. And again, the upgrades are good because they can be made. You don't have to make an upgrade of your application or the entire application. You can upgrade only 20% of the users will see the first upgrade. If they are not happy, you can roll back. If they are happy, you upgrade 60% of the users, and then 100% when you feel that you are confident about your application. This is a lot better than the monolithic architecture that the whole application, every time you needed to upgrade, you needed to stop, have a downtime of your application to be able to upgrade your application, release a new. We know this, we do this all the time. So yeah, it's a lot more flexible. So how can we use Docker in Citgo? I took this description overview of ITS. ITS is one of the applications that Citgo has that most of you know, like it's very important for the company. And we are not going to read this because there's a lot of detail on it. And I tried to look at it and remove from it the core functionality of ITS. And the core functionality of ITS will be like moving files internally on the network. So move files from many different places, secure FTPs, message queues, zip and unzip files, decrypt and encrypt files, archive those files, and has to log everything that it does, because this is very important to know exactly what the whole application is doing, so we don't miss anything. How can we Dockerize this app? Well, how can we apply a microservice architecture to it too? So we would start by creating different containers. For example, we have our ITS admin, that is the user interface where the user can configure the schedules, the push destinations. So we would probably create a container for it. And we will start a container instead of having it sharing the same physical hardware with different applications. We will try to isolate it. The same thing can be done with a database. Microsoft is working in a SQL server that would run over Linux inside the Docker container. And there's already some alpha release with this. So this is a big change. Microsoft is installing SQL Server over Linux. It's interesting. Another thing, we can create an application called Workloader. I will describe all of these applications in the next slide. So this is the overall picture of the thing. So now I'm going to explain. So the ITS admin already said there's nothing new here. It's just a web application that writes data into a database. ITS Loader would be an application that would retrieve the configurations from the database and start creating working items into a queue. So it will just do that. It's a very simple process. It's analyzing what configuration it has and start creating these work items. Then we will have another small application or service that will be ITS Orchestrator that would be constantly listening to this queue of work and measuring how much work needs to be done. And let's imagine that there will be 100 work items there. So this application will be smart enough to know, okay, if I have 100 work items, I'm going to start 10 workers. If I will have 1,000 work items, I will start 25 workers. So I will be able to execute my work faster. So, and this is the flexibility that microservices and Docker brings, because it's really fast and easy to spin up these workers and multiply them. You just need to have hardware for it, and start running them. The worker will be, again, a very dumb application. Would be listening to the queue, would start up, pick up an item from the queue, and execute that work. And this is just an example. So would be in that instructions of work would be something: get the file from this source, unzip it, send it to destination A, B, and C, archive that file, and delete it from the source. Well, and you will have to log all this, of course. So this is an example. As soon as the ITS worker finished the work, it shut down and released the hardware for other worker that might be starting right now. So, and now that we know everything about containers and Docker, in a very high way, I would like to make a demo of, I'm gonna create a web application first. So I will explain the demo first, and then I will execute it. So I will create a web application. I will create an image for that web application, a Docker image. Then after that, I would, so Docker works like this. You have to create images, and then from those images, you can create any containers you want. So the image would be kind of the source that could be replicated 1,000 times. So you just create, back into the ITS example, you just do an image of the worker, and then you can spin up 100 workers if you want. So what I'm going to do, I'm going to create an image of ITS. Of the web application, ASP.NET web application. I'm going to show you how you do this, how you create the image. Then I'm going to spin up a container of that image on my local machine. After that, I'm going to grab the image and upload it to Docker Hub. That is the registry, kind of the store. I'm going to explain how it works. Then I'm going to other environment. In this time I will going to start in Windows. Then I'm going to go to macOS. There is a different operating system. I'm going to pull down that image from Docker registry, and I'm going to spin up a container, this time on the Mac. And we will see the application running on the Mac that was developed in Windows. Okay, so let me just start here, Visual Studio.
You write it down?
Yeah, this might fail, No, but let's see. I think it's not gonna fail. I might skip some steps because the internet is a bit slow, so I'm gonna skip the steps of uploading and downloading because I already have all those images ready. But so let's start new project.
You're not in simple environment here. This is all. This is.
Yeah,
this is private.
We are outside. Yeah, and this application doesn't have anything from C. It's just a sample web application. So I'm gonna call it Docker Web App. Okay, this will be a ASP.NET 5. That is the latest. That runs everywhere. So I'm going to remove the authentication because we don't need it, and create a new web application. This is the sample applications. When you start from scratch a new web application, it has like an initial home page, contact page. Okay, it's restoring the packages. That's fine. Now, one thing I need to check is the project.json, just to be sure that my application will run on the port that I want. Okay. It's the first time that it's running. So this is the application. It's something very simple. As a carousel that shows what technologies it's using, where it can be deployed. It runs everywhere. So the ASP.NET 5, it's a new version of .NET, uses a new version of .NET called .NET Core. It's a .NET that was developed from scratch to run everywhere. So it's
open source, isn't it?
Yeah, and it's open source. So the application is running. And I should remove this notification. Just remove this. Disturb. Now, I just need to say here that I want to use a specific port. For that, I have to do this server URL, and HTTP, and I want to use the port 5000. So my application would run using Castro and would start on port 5000. Now what I need to be sure is that this would work in my local machine, because if it doesn't work on my local machine, it's not going to work inside the container. Okay, looks better. Okay, the application is now running as a self-hosted application, so it's not running in a web server, it's not running in IIS, it's running as an executable file, self-hosted. Let's go now to Docker, that's the core part of this presentation. And Docker works with a client and a server application. So right now I'm in the terminal of Docker. I'm connected to a Docker engine. And I can do things like, for example, Docker images, and I can see what images are installed on my engine. And I can do Docker PS and see how many containers are running, for example. I don't have any containers running at this moment. So I want to build my image. So to build my image, I need to make sure that from this console, I can see the project files that I was working on. For that, I'm gonna have to change directory and go to C, documents, users, Javas, documents, projects, Docker, web app, source, and Docker web app. And now I can check, okay, here are the files of my project. This is what I want to have inside of my container. To be able to create a Docker image, you always need a Docker file. The Docker file is a manifest of instructions to build that image. So I need to write my manifest of instructions to build the image. And I'm going to do that using Vim. So Docker, Vim Docker file, and I'm going to start writing my manifest. And it's very, very simple. It's in plain text. So from ASP Microsoft ASP.NET. So what this instruction is doing is like, I want to base my image in another image that already exists, created by Microsoft. It's a Docker image from Microsoft, and it's called ASP.NET, and is hosted in the Microsoft kind of host. That image has everything that the application needs to run. So it has the .NET framework and all the dependencies that my web application needs to run. So this is why I do this command. It's very interesting, and I think it's important to explain that Docker works by layers. So when you are building an image, you always base your image in other images that exist. There's a image called null, let's say, that you are starting the first one, and then you can build over it. And the latest, the top layer is the only layer where you can have privileges to write something. All the underneath layers are read-only. For example, I cannot change this layer of Microsoft. I cannot go there and change something. Okay, so next step, copy. This is the copy command. All the files that are in my current directory to a folder called project. Second command will be, okay, my working directory, I want you to move to the folder project. And my fourth command will be run dnu .NET utilities. So this comes with the image that I'm pulling first. .NET utilities restore. So what this instruction does, apart from creating another layer of Docker, it will pull all the dependencies for the project. But now we are talking about NuGet packages of the web application, so things that the application needs to run. And the final instruction will be entry point, and it's another command. It's going to be dnx web. Web is the command that dnx is .NET executable runtime, so it's what's going to start up the application. Web is the command that is on this file. You see there, command web. So it's going to execute Kestrel on port 5000. And I have to specify again that I want my server to start on that specific port. So I do that thing again, server.url, and I do something like HTTP 0.0.0.0 port 5000. And that's it. That's the Docker file. It's just these 5 lines. And here are all the instructions that Docker needs to start building the image. So I'm going to save this file. And I'm going to run again that command that I tried that failed before. Version 1.0, Docker web, all the files, filled. And what Docker is going to do now is going to start reading those instructions and start building the image for me. And now this is a part that is going to take a long time, so we might skip it. That is when it's downloading all the dependencies, the NuGet packages. So as you can see, everything that the application needs to run, it's being downloaded now inside the container already. So this is being executed inside the container. The image, sorry. The container is an instance of the image.
Does it get all versions of .NET or just the latest version, or can you specify?
Just works with this version, the core version.
Oh, it's just core version.
Jack, I don't know if that's something else to ask. But if you're building up an image layer by layer, right? So say you have a .NET layer and then the app. So then you've got one image. Now .NET will require an upgrade from time to time. How does that manage itself? Do you need to build another image?
No, you can roll back layers.
Say you're completely happy with your image. Time passes. And then, I don't know, for security reasons, whatever, you want to patch, the next version of .NET applied down here.
That's fine. You can just change your Docker file.
You rebuild the image.
Yeah, and rebuild all it. From the point that you don't have to rebuild the whole image, but from the point that you want that when you change the where you set up which .NET framework you want to install. So
That
that
would be interesting if there was a change, a minor change of the .NET version on
the thing is
that mess with the image.
the thing is you sometimes you don't even need to update. Not only if you have a reason to do that. But the idea of containers is that you can run different versions of the net side by side in the same server,
Yeah.
and none of them affect the other applications. So everything is isolated.
So I think what I'm hearing is the interaction between the container versus the underlying OS. There's no dependency between the two.
No.
So once
Yeah.
you build a container, everything is totally contained within a container, and your underlying OS can be changed and patched and so forth. Your Docker will continue to run.
But that's why one of the reasons why the Docker icon is that way with the actual shipping containers on it. Your shipping container doesn't matter what ship it's on.
Yeah.
It's totally independent.
While this is done,
Ocean as well.
while this is downloading the packages, we can have a look at the Docker page because we need to create a repository for that image that we are creating. To do that is very easy. You have to have an account.
So the promise of Java in the early days is write once, run many, right?
Mhm.
This is yet another promise, but instead of at the Java application layer, it is at the essentially a whole application within a container.
Yeah,
Same
yeah,
as-
exactly. That the idea is your container can run anywhere, and then you have full control over what's in that container.
And just on that point then, so why would you upgrade .NET? Let's say it's external facing. Your vulnerabilities are recognized, and then you're kind of encouraged to tap in, which is the .NET is along. So the mechanics of that, would you take an image and kind of I don't know what it is, unbuild it down to a you have to build a new image from scratch, right?
If you want to restore a different version of .NET, yes,
Yeah.
because .NET Now is a NuGet package. So this is actually downloading .NET Now.
Well, yeah, that's how I understand it. You would build a brand new image with the
Yeah.
new dependency, and then you would fire that out into your
Yeah.
deployment environment and tear down your old images.
So it'll be a new job description, kind of keeping an eye on all that.
Maintaining the containers, yeah. Maintaining the images.
So what I did just now was create a repository for this application, for this image. And what I'm going to do next is push that image into Docker Hub. So then I can download it anywhere I want, in the cloud, in another environment, in a data center. Just need to have access to the Docker Hub.
Is there one centralized
Repository.
repository for your? So say I've got you build your source image, and then you deploy it, and then 20 containers spin up. Could you have a situation where you've got you deploy a new package, but 10 of your containers are on the old, and 10 are on the new, or how does it keep itself constantly up to date?
I think that you'll have to use a different tool to manage that.
So there is that.
Or maybe the Docker Swarm or the Docker Composite. I'm not sure which one it is, but I know you have a tool where you can configure those things and see which version are running in
There
each.
is something in the
So I think you're looking at the next level, right? So code will evolve over time,
Hmm.
and this gives us the potential of pointing certain users to one version of the app, and then other users to another version of the app. So you can start to salt and pepper,
Yeah.
or
Mhm.
bimodal, I guess is the more appropriate term, to kind of transition certain kind of beta users into the new
Exactly.
version. And then, but that's not what this is about. This is just creating the Docker object in and of itself. There's other tools around that to kind of
Yeah.
point certain users to certain versions. Is that right? You're saying?
So exactly. So this finished the process. Now we can see it downloaded 191 packages. So our image is ready. So now we can list our images and see if it's there. Yeah, it's there. It's called Jaguar's Docker Web. Was created a minute ago. So what we can do with this now? we can run it. To run it, I just have to do docker run. So what I'm going to do now is grab that image and create the first container of that image, so the first replica of the application. I specify again the port where I want that to run, 5000, and the name of the application. I think that's it. Okay. And now let's see if it's running on my local machine. There it is, it's running. And we can prove that by show the console. We put side by side. If I change here, for example, to about, you see, that's the container running, or contact page. Now I'm going to stop the application.
One sec, I was going to say, can you run two containers side by side with the exact same thing in it on different ports?
Yeah. You just run another instance.
Could you do that?
Yeah. I just need to open the ports in the VMware.
Oh, okay, don't worry.
Because the port
Yeah.
needs to be open.
Okay, but it would be as simple as just another run
Yeah,
command with a
I
different
can
port
run
number.
it. I can run it actually. I'm gonna spin another one in port 4001 now. There you go. Now we have two applications running. How can we see that? Docker PS. There you go. One was created about a minute ago, another 8 seconds ago. One is running in port 5000, another is 5001. Now I can do things like Docker stop. Docker stop does what the name says, stop the application in a graceful way. But if you want to stop it really, really fast, you can use Docker kill. And Docker kill would kill the process, so it's much faster. But it doesn't shut down the application in a graceful way. So it's funny that you see those names here. Compassionate, Lalande, Angry Lovelace. So these are names that Docker gives to your containers automatically, and sometimes gives really crazy names. So and this is how you stop them. So you say like Docker stop, Angry, Lovelace.
See that on V1 calls.
I have Docker 2 times. It's stopping one container. You see that takes time, and now I'm gonna use the kill, and you can see this is much faster. So Docker kill compassionate. It's instant. The application now is not running, as we can see. If we try to refresh, can't find the website. That's okay. So now, what would be the next step? Push this guy, the image, to the cloud, to the repository, right? So that's very easy to. We just need to do a command like docker push jagush ASP net, and the version that would be, I don't have to specify, I want the latest one. So I guess that's it.
What size are these images?
So this is very interesting too. Docker is able to measure the size of the image because of this layer system. It will not try to push everything. So it just push what doesn't have. It's the same thing when you pull down.
Yeah.
For example, because my image depends on the Microsoft ASP.NET,
yeah,
it will not try to push that part of the layer every time I do a pull.
That's cool. Does
So
it have
that's
a
very cool.
repository like Maven, or does it have its own repository then? Do you think?
I think this is something that was developed specifically for Docker.
Right.
But there are images that's good. That's good to show. It's good that you talk about that. In the Docker Explorer, if you go to Docker Explorer, you can see all the images that they have available, official images that you can download and start and use in your project. So again, following the same approach of the microservice architecture. So you can download the database, Postgres, or HTTPD server, web server, images of CentOS, or Fedora, or Ruby, or PHP, Tomcat. You see it, Java virtual machine, Python, Rabbit message queue. So this is like Legos, right? You have all these pieces and you start building your application by putting them all together. This is how it's gonna work. It's fun, no?
Like that, yeah.
Lego is cool. Okay, you see Oracle, Linux, Cassandra, Ghost. Okay, so let's imagine that the internet was super fast and we already pushed the image into the Docker Hub, and now we are going to the Mac. So the Mac, we are going to start again the Docker console terminal. This time on the Mac. And I don't like this console like white. I don't know why it's white. I prefer dark. Sorry. Let's see if I can. Yeah, no. Strange. Okay, it's because it's easier to read. So I'm gonna zoom in so you guys can see. But it's the same. It will be the same thing. So Docker images. I have one here already. So to download the image, we do Docker pull ASP Jaguar ASP.NET. It's gonna grab the latest, and now what's gonna happen? You see, already exists. So I try to pull an image that my engine already has. So it's not gonna download it again. It's gonna tell me, hey, what are you doing? You already have this. So okay, cool.
But that's not because you had it on the Windows side. It's a different Docker
Yeah,
runtime. It's just you had downloaded it here before.
This is a different runtime. This runtime is running on macOS. Yeah. So what can we do next? We can fire up this image, a container of this image. So Docker run on port 5000 Jaguar ASP.NET, and yeah, that's it. Okay, now let's open Safari and localhost 5000, and there we go. Our application is running now on a Mac. Yeah, and that's the end of the demo. Then there are other commands like to remove images, to remove containers.
Yeah, we might wrap it up there. If anyway, that's a good time to go for questions and stuff.
Sure. I think